nila. Gawa! We're here to report about the electrochemical cells, their properties, and uses. Here's Ada to begin the report. Hello, my name is and I'm going to report about the nickel metal hydride cell. Nickel metal hydride cell. Nickel metal batteries are related to steel nickel cadmium batteries and only differ from them in that instead of cadmium, hydrogen is used as the active element as a hydrogen absorbing negative electrode. This electrode is made from a metal hydride, usually alloys of lanthanum and rare earths which serve as a solid source of reduced hydrogen that can be oxidized to form proteins. The electrolyte is alkaline potassium hydroxide. The cell voltage is 1.2 volts. Nickel metal hydride batteries are related to steel nickel cadmium batteries and only differ from them in that instead of cadmium, hydrogen is used as the active element as a hydrogen absorbing negative electrode. This electrode is made from a metal hydride, usually alloys of lanthanum and rare earths that serve as a solid source of reduced hydrogen that can be oxidized to form a proton. This electrolyte is alkaline potassium hydroxide. The cell voltage is 1.2 volts. It is a type of rechargeable battery similar to a nickel cadmium battery but using a hydrogen-absorbing alloy for the negative electrode instead of cadmium. It is a type of a rechargeable battery similar to a cadmium battery but using a hydrogen-absorbing alloy for the negative electrode instead of a cadmium. It is a type of rechargeable battery similar to a nickel cadmium battery but using a hydrogen-absorbing alloy for the negative electrode instead of cadmium. As in NACB, the positive electrode is nickel oxyhydrox and the capacity of an equivalent can be 2 to 3 times the capacity of an NICB. However, compared to the lithium-ion battery, the volumetric energy density is lower and self-discharge is higher. The components of a nickel metal hydride cell is a cathode of nickel hydroxide, an anode of hydrogen-absorbing alloy, and a potassium hydroxide electrolyte.
Let's drop! Lithium SO2 cell, a method of cell, an electrolyte, and an adenine for the non-dendritic deposition of lithium in its. The additive causes the non-dendritic disposition of lithium from non-aqueous electrolytes, and particularly organic electrolytes, is a metal reducible by lithium and capable of forming lithium-rich metallics or alloys. A rechargeable cell capable of plating non-dendritic, which comprises a sulfur dioxide cathode, a lithium anode, and a product comprising a non-aqueous solvent, having dissolved during a lithium salt and in addition agent, comprising a metal salt which is reducible. A rechargeable cell capable of plating non-dendritic, which comprises a sulfur dioxide cathode, a lithium anode, and an approaching non-aqueous electrolyte. Instead, electrolyte comprising a non-aqueous solvent having dissolved during a lithium salt and an addition agent, comprising a metal salt which is reducible by lithium and capable of ablating therewith, and wherein the concentration of said addition agent does not exceed the amount, which will render the plated exceed lithium at least 1.5 volts more novel than the normal lithium EMF activity.
about lithium iodine cells. Lithium iodine cells is a solid electrolyte. It is highly used in medical applications. It does not generate gas even under short circuit, solid state chemistry, and limited short circuit. Suitable only for low current applications, terminal voltage decreased with degree of discharge due to precipitation of lithium iodide low self-discharge. Lithium batteries find application in many long lives. Critical devices such as artificial pacemaker, other implantable electronics, and medical devices. These devices use specialized lithium iodide batteries designed to last 15 or more years. But for other, less critical applications such as in toys, the lithium batteries may actually outlast the toys. In such cases, an expensive lithium battery is not cost efficient. The heavy electrical demands of many of these devices make lithium batteries a particularly attractive option. In particular, these batteries can easily support the heavy current demands of devices such as digital cameras, and they maintain a higher voltage for a longer period than alkaline cells. So, other lithium batteries use a platinum iridium alloy instead of more usual compounds. These batteries are usually not preferred as their cost is high and they tend to be fragile.
You home if you don't leave me at the front door.
Lithium iodine cells are very commonly used in small portable electronic devices such as CD8, watches, thermometers, calculators, remote car alarms, backup batteries in computers, communication equipment are available in many shapes and sizes. Lithium iron disulfide can be used for digital products such as digital cameras, digital videos, CD8, flashlights, motor-driven devices, powerful electronics. But it is not quite straightforward. Video, audio, video devices, MP3s, MD players, and CD players.
My name is Jabel and Nila. I'm going to talk about lithium ion disulfide batteries, or LiFe, S2 batteries. Lithium ion disulfide battery is the latest developed battery series. It is of 1.5 volt operating voltage, high energy and light weight, and good performance at high temperature or low temperature conditions. So it can be widely used for. These are the features of lithium ion disulfide. One, it is direct compatibility. It is used in any application using primary 1.5 voltage battery type. And number two, it has high discharge capacity. It is 6 times longer service than normal alkaline battery under high drain applications like digital cameras. B, it is stable and higher operating voltage than a normal alkaline battery. It has 10 years shelf life. It has low rates of discharge rate, and it is light in weight and environment friendly because it has no mercury, cadmium, or lead added. It is number three is the safety performance. Possesses for safety